We can use Fourier series methods for endpoint value problem. We also call this one a boundary value problem. So we are given this ODE: A times x double prime, B times x prime, C times x equal to ft. T here between 0 and L. So we have two endpoints, 0 and L. So assume that this condition we have x0 equal to xl equal to 0. So we are given this type of question. And this boundary condition, we call that the condition of Dirichlet type. So another type is a Neumann type. They can give you x prime at 0 equal to x prime at L equal to 0. So depending on the type, we use the Fourier sine series or Fourier cosine series. And we can solve this ODE to get the formal Fourier solution. Solve for xt. And we get the so-called formal Fourier series condition solution. Xt summation. So in this case, I do the example for the Dirichlet conditions. For the Dirichlet condition, I could have a Fourier sine series Bn psi n pi t over L, n from 1 to infinity. So here's the reason why I use Fourier sine series. For the Dirichlet condition, you have x at 0 equal to summation Bn psi 0. When you plug in t equals 0, you get psi 0. Psi 0 equals 0. This one is 0, which match our condition. X at 0 equal to 0. And if you do x at L, t equal to L, you had summation Bn psi n pi L over L, so psi n pi. This one's also 0. So that's explain why for Dirichlet condition we use Fourier sine series. Dirichlet condition use Fourier sine series. And for Neumann condition, you use Fourier cosine series. So here's why. If you have cosine, summation of something, say a0, an cosine prime equal to psi, and you plug that in, you get 0. So that's why for Neumann condition you use Fourier's cosine series. So now let's do this example when we have Fourier's sine series. Let's do this. So step 1, check the boundary condition. We solve this boundary value condition. Check the endpoint condition or boundary condition. If we have directly, this means x at 0 equal to x at L equal to 0. We use Fourier sine series. If we have Neumann condition, which is x prime at 0, x prime at L 0, we use Fourier cosine series. In this example, we have Dirichlet condition. Let me do it for Fourier sine series. Let's write down the Fourier sine series of x. Xt summation bn sine n pi t over L, and from 1 to infinity. We want to find the coefficient bn, and when we find it, we get the formal Fourier solution. Formal Fourier series solution. So let's try to find Bn. From this ODE, you need to compute x double prime, x prime, x, and you need to compute the Fourier sine series of ft. We do Fourier sine series in this case. So we need to compute Fourier sine series for ft. Step 2. Compute Fourier sine series of f. So ft is given to us. Ft is given to us, a forcing function. So compute the Fourier sine series of that forcing terms. Summation, let me say big Bn sine n pi t over L, and from 1 to infinity. Big Bn is given by 2 over L, 0 to L. Ft sine n pi t over L dt. So you need to compute that. Step 3. Plug in all what we computed into this ODE. So step 3. To the ODE. So in this case, you need to have x double prime. You need to have x prime. Compute that. Compute ft. So for example, xt is this Fourier sine series. Under the condition x is a piecewise smooth function, we can do differentiating terms by terms. X prime t. So we assume that we can do it. We do differentiating terms by terms. X prime t summation n from 1 to infinity. Bn psi prime is cosine n pi over L cosine n pi t over L. X double prime t, we do differentiating terms by terms. So that's why we assume the function x is so nice, so we can do that. That's why this formal Fourier series solution, we call it formal because it's a summation, infinite sum. See? and it is under the condition we can do all this. So this is not the actual solution. It's subject to verification whether it's indeed satisfy the condition piecewise smooth or not. And from 1 to infinity, Bn n pi over L cosine prime minus sine n pi over L sine n pi t over L. So x double prime t summation Bn minus Bn n square pi square L square sine n pi t over L. Now we have everything. We can plug in this ODE and we solve for the coefficient Bn. You do coefficient of sine n pi t's left hand side. You group one on the coefficient of n pi sine n pi t over L equal to the coefficient of sine n pi t over L on the right hand side. Coefficient of sine n pi t over L from the left hand side equal to coefficient of sine n pi t over L on the right hand side. For all n greater than or equal to 1, and then you solve for Bn, and that Bn will give us coefficient for psi here in the Fourier sine series of xt, and therefore we have a formal Fourier sine series, formal Fourier series solution of this boundary condition. Let's do one example. Find the formal Fourier series solution of x double prime t, or I just write x double prime 2x equal to 4t. The boundary condition is x at 0 equal to x at 1 equal to 0. So we know that this is the Dirichlet condition. We use Fourier sine series. So xt summation Bn sine n pi t over L. L in this case equal to 1 because it starts from 0 and n is 1. L equal to 1 divided by 1. Now we need to find the Fourier sine series of ft for t. So 40 equal to summation Bn sine n pi t over 1, and from 1 to infinity Bn 2 over L 2 over 1 0 to 1 ft 40 sine n pi t over 1 dt. We need to compute it. So 8 0 to 1 t sine n pi t dt. We do integration by parts. This one is 8 times minus 1 to the n plus 1 over n pi. This is our Bn for all n greater than or equal to 1. Now we can substitute everything into the ODE here. We need x double prime. X double prime, I wrote it right here. For our case, x equal to this Fourier sine series x prime. I do first x double prime summation minus Bn n from 1 to infinity n square pi square sine n pi t. This is our x double prime. So this equation now becomes summation here for x double prime 2 times summation, so plus 2 times this for xt two times x equal to 40 Fourier series of 40. Fourier series of 40 is equal to this. 40 equal to summation of Bn. Bn, we computed that. This one. So this is a Fourier sine series of 40. Equal to this. So that is the right hand side. 40. Now we group all terms with sine n pi t and let the coefficient of the left equal to coefficients of the right. Left hand side you have n from 1 to infinity Bn sine n pi t in common. I can group that. Bn sine n pi t. Inside we have minus n square pi square plus 2 equal to the right hand side. So you see here as we have sine n pi t, sine n pi t. So let the coefficient here be the same. For all n greater than or equal to 1, Bn times this equal to this. Bn equal to 8 times minus 1 n plus 1 n pi times 1 over 2 minus n square pi square. This is our Bn. So the final solution is from Fourier series solution is xt equal to summation n from 1 to infinity. This one times sine n pi t. Can write a bit nicer. 8 minus 1 n plus 1 n pi 2 minus n square pi square sine n pi t. Remember that this solution is subjected to verification of whether we can do differentiating term by terms as we did. The question in general, we always ask it to compute the formal Fourier series solution. So we can conclude here. This is our formal Fourier series solution of the boundary values problem.